June 30th, 1908, 7:14 in the morning. A flash brighter than the sun tore across Siberia. 80 million trees fell. Break time, 500 mens, and no crater ever appeared. The gravity matrix. Here at the Gravity Matrix, we investigate new atmospheric evidence. For over a century, two theories dominated this case completely. Asteroid or comet, physicists have argued both for decades. New 2026 analysis of century-old sky records changes everything. A researcher's preprint claims neither explanation survives close scrutiny. That claim alone should unsettle a century of settled science. To understand why, we return to that Siberian morning first. The blast released 10 to 15 megatons of raw energy. That's 1,000 times the force of Hiroshima's bomb. Yet the object detonated 5 to 10 kilometers above ground. No impact site, no fragments, just devastation and silence. 2,000 square kilometers of forest lay flattened outward. The pattern wasn't radial, it resembled a butterfly's wings. That shape alone would become a century-long forensic clue. For 20 years, no scientist even visited the site. Soviet mineralogist Leonid Kulik finally led the first expedition. Kulik expected a crater. He found flattened trees instead. Decades of searching turned up no meteorite fragments anywhere. That absence became the central, unsolved puzzle of Tunguska. Meanwhile, something stranger was happening across Europe that week. For several nights after the blast, the sky refused darkness. In London, people read newspapers outdoors at literal midnight. 5,000 kilometers from Siberia, with no visible connection. Two rival theories would eventually try to explain it. One says asteroid, the other insists on a rogue comet. Neither until now has explained those glowing European nights. What we found in the atmospheric data breaks both stories. The asteroid theory begins with a 2001 trajectory study. Researchers at the University of Bologna modeled the object's path. Giuseppe Longo's team calculated an 83% probability the object likely originated from the main asteroid belt. But probability isn't proof, and the physics gets complicated. A stony asteroid needs real structural integrity to survive descent. Physicist Christopher Kaiver modeled exactly how that survival works. His fragmentation model explains the airburst altitude precisely. Enough strength to reach 5 kilometers before catastrophic failure, releasing nearly all its energy in one violent instant. The competing theory points to a completely different culprit. June 30th falls during the Beta Taurid meteor shower's peak. That shower originates from periodic Comet Encke's debris trail. A large rogue fragment could explain the object's arrival timing. Comets are fragile, built from ice, dust, and gas. A cometary nucleus disintegrates at far higher altitudes typically. That's the first real crack. The altitude fits neither model. If this changes how you see the sky, subscribe now. For a century, only two answers competed for Tunguska's truth, but neither theory ever addressed the glowing night skies. That's where researcher Andrei Orkovatov entered the investigation. His 2025 and 2026 preprints re-examined century-old Smithsonian records. The Smithsonian Astrophysical Observatory logged atmospheric anomalies back in 1908. Orkovatov argues those anomalies fit neither asteroid nor comet physics. He points to anomalous atmospheric pressure readings that same week. Those readings suggest atmospheric gravity waves rippling through the sky. A geophysical mechanism, not a simple space rock impact alone. Important context, these papers are preprints, not peer-reviewed yet. That distinction matters, and we'll treat the claim carefully. So what would you have concluded from this data? 3 independent record sets agreeing. That's a real signal. Not noise, The 2013 Chelyabinsk airburst sharpened these very models. Researchers used Chelyabinsk's fireball to recalibrate atmospheric fragmentation physics. Suddenly, old Tunguska assumptions needed a second, harder look. That's what everyone believed for decades. The data disagreed. Planetary scientist Natalia Artemyeva has modeled airburst physics for years. When new data arrived, her team checked twice for errors. Everything about this case was about to change again. The next dataset doesn't add nuance, it reframes everything. Because what comes next changes the entire investigation. Here is where the asteroid versus comet debate collapses entirely. Olkhovatov's atmospheric optical data contradicts both leading interpretations directly. Neither theory predicts multi-night sky brightness this fast or lasting. Let's return to those bright European nights in full detail. For days, twilight refused to fully surrender to darkness. Astronomers recorded elevated airglow across thousands of kilometers away. An asteroid airburst releases heat, light, and shockwave, nothing more. It doesn't explain glowing skies 5,000 kilometers away. A comet fragment offers even less atmospheric staying power. So what mechanism could ripple that far, that long? Olkhovatov's answer: atmospheric gravity waves, not impact debris alone. Picture the atmosphere as a pond after a stone drops. The energy doesn't just vanish, it radiates outward as waves. Those waves can alter upper atmosphere chemistry across whole continents. That's a mechanism neither the asteroid nor comet camp model. The pressure anomalies recorded in 1908 support this exact idea. Barometric records show oscillations that shouldn't exist naturally otherwise. This is, in our view, the most overlooked dataset. The most obvious objection: instrument error across century-old barometers. Olkhovatov spent considerable effort ruling out systematic measurement drift. The anomaly held even after conservative corrections were applied. That doesn't prove it, but it strengthens the case significantly. Remember, this remains a preprint, not yet peer-reviewed science. Responsible science demands we say that plainly, out loud. Still, the implication is staggering. Tunguska may need 3 explanations. Not asteroid or comet, but atmosphere physics too, apparently. 3 independent forces, converging on one Siberian morning in 1908, that reframes a century of either-or thinking completely. A single anomalous spectrum wouldn't normally make headlines alone, but 3 independent lines of evidence change the entire calculus. So what would you have done with data like this? Would you defend the old theory or follow new evidence? Most working scientists chose the harder, more honest path. They're still testing, still modeling, still refusing false certainty. That intellectual humility is what real science actually looks like. If the next reanalysis confirms these gravity wave signatures, everything shifts. If it doesn't, the 2-theory consensus survives another round intact. Either way, Tunguska remains our planet's largest unexplained airburst event. It previews every future object we haven't yet detected. What we thought settled in 1908 is a question again. Let's zoom back to what this means for us today. Tunguska isn't Apollo-era history. It's a live detection problem. No warning system existed in 1908. Barely one exists now. An airburst this size over a city would be catastrophic. That's not fear-mongering, that's basic orbital mechanics and statistics. Here's what this Apollo generation should watch for next. If their Rubin survey flags a similar object early. If Olkhovatov's gravity wave data gets peer-reviewed, physics textbooks update. Either outcome makes that quiet morning more important, not less. This is, in our view, an underrated astronomical case file. We start with a flash brighter than the sun itself. We end with a question no theory fully answers yet. Asteroid, comet, atmosphere, maybe all three working together somehow. That kind of uncertainty isn't failure, it's honest science working. The iron and carbon in your body came from stars. The same physics that flattened the forest built your blood. Cosmic violence and human existence share the same raw materials. That thread connects a Siberian morning to your own body. We track every dataset release so this thread survives. Subscribing means you'll see the next reanalysis first, decades on. 118 years later, the case is still open. New instruments, new archives, new researchers keep reopening old questions. That's what real scientific progress actually looks like, slowly, honestly. Not sudden certainty, steady correction, one preprint at a time. Somewhere in an archive, another anomaly waits to be noticed. The next Tunguska scale event won't wait for our detection systems. That's the sobering, quiet stakes behind this entire investigation. We may never fully resolve what happened that June morning, but refusing easy answers is exactly what keeps us honest. What we know now already rewrites a century of assumptions. Of every case this observatory has covered, this one lingers. A flash, a silence, a sky that wouldn't go dark. 3 theories, one unresolved morning, and a question still open. We'll keep tracking every dataset that touches this case, because somewhere in that data, the real answer is waiting. If this investigation moved you, there's more waiting for you. Full breakdown and every name source pinned in the comments. We're already tracking the next reanalysis of this exact case. Subscribe to see it the moment new data actually arrives. Case file linked in the description. The investigation continues.